Okay everyone, hello and welcome back. Today we're going to take a look at finding the LCM and GCF and essentially just trying to highlight their main differences. So LCM stands for the lowest common multiple, also sometimes read as the least common multiple. There are two methods of finding the LCM, but the easiest one is obviously to learn the tree diagram of prime factorization. For example, between the two numbers 12 and 15, in order to find the least common multiple, first you have to divide them into their prime factors, which is something you should already be familiar with. So 12 can be broken down into 6 and 2, for example, 15 into 3 and 5, which cannot be further simplified because 3 and 5 are already two prime factors. 6, however, can be broken down into 2 and 3. Okay. Now, when it comes down to essentially listing, finding the LCM, you have to take a look at the prime factors. Now, if a factor appears more than once in any of these numbers, and note when I say in any of these numbers, you have to list it that many times. For example, 2, right, does not appear in 15, but appears in 12. So you can list it. So you can write 2 to the power of 2. Right, which would not be the case with the GCF, the greatest common factor. And then you can write 3 to the power of 1 because it appears one time in both the numbers, and then 5. If you multiply both of these, you get essentially 4 times 3 times 5, which would be 12 times 15, which is essentially 60. So what I did, step 1, I basically listed all the prime factors. Step 1 is to list all the prime factors. Then I would take a look at both of these numbers, and if a prime factor appears more than once in any of these numbers, I would list it that many times. So step 2 is if a factor appears more than once in one of the numbers, list it that many times. And the final step is to obviously just step 3 would be to multiply those factors together to find what your LCM is. Let's go ahead and take a look at another example. For example, let's say we get something like example B would be 18 and 30. So the first step is to obviously try to break this down into its prime factors. If you break this down to its prime factors, 18 could be broken down into 3 and 6, and 30 into 3 and 10. So 6 can be broken down into 2 and 3, and 10 into 5 and 2. Now, the greatest common factor here between these two numbers are essentially any of these prime factors that appear more than once. So you have to list it at the number of times it appears. So for example, 3 is a prime factor and it appears 2 times. So you write it down the greatest number of times it appears. So 3 to the power of 2 times by 2 to the power of 1. And there's also a 5 right there, so you write 5 as well. The answer will be 9 times 2 times 5, which is 18 times 5, which is essentially 90. Now, what happens when there's more than 2 numbers? For example, you got 3 numbers, or for example, you have essentially a variable like an x or a y. Is it going to be any different? Yes, there is going to be a difference, and here's how it looks like. For example, for C, let's say we get something like 6a squared and 18a cubed. Over here, what happens is this. First, you have to break down 16 as 6a squared, which is essentially 6 would be 3 times 2 times a times a. That would be a squared. And then 18 can be broken down into essentially 9 times 2, but you can break the 9 into 3 and 3 times 2, basically trying to break it down into its primes, times a times a times a, because it's a cubed, and a cubed is a times a times a. Each one has a power of 1. All right, now the common factors between these are obviously 3, 2, and a. But do we write it the least number of times? No. We actually see the greatest number of times that it occurs in both of these numbers, and we write it down, contrary to the name, lowest common multiple. So you just write this, you say 3 to the power of 2 times by 2 to the power of 1, because it's repeated one time in both numbers. And the greatest number of times a is repeated would be 3. So it'd be 9 times 2, which is essentially 18, times a to the power of 3, which would be 18a cubed. Now, what is the difference when we're trying to find essentially the greatest common factor? The greatest common factor's difference is going to be this. So if this is the GCF and this is the LCM, the main difference is going to be that when you're trying to find the greatest common factor, you only list the number if the factor is repeated in both the numbers, not just one of them, but in both of them. For example, 3 is repeated in both the numbers, but it's only repeated 2 times in the second number. So you write it the greatest number of times it's repeated in both the numbers. So it would be 3 to the power of 1 multiplied by, and then 2 is repeated one time in both the numbers, so you write 2. And then the greatest number of times a is repeated in both the numbers is a to the power of 2. So it would be 6a squared. Right? So this would be the greatest common factor. This would be the lowest common multiple. So when you're trying to find the greatest common factor, you should only bring the prime factor out that is repeated more than once, or however many times it's repeated in both the numbers. But for the LCM, you bring it down even though it might be repeated in one of the numbers. For example, in 18, 3 is repeated 2 times, so it's 3 to the power of 2 for the LCM. But for the greatest common factor, it's only repeated one time, so you write it one time.